Today, in your text for the last few days, you started to read the information in section review over humidity and condensation and evaporation, things like that. What we're going to do today is go through and look at those. The first thing you need to do is in your notebook, I've got, I believe, 9 vocabulary words that we need to make sure that we know for sure and get those in. So what I've got is a presentation here, a PowerPoint. We're going to put it up here. It's not real dark because of the light, but you should be able to see it. And we're going to go through those words one at a time and make sure you understand each one of those. So copy it down as we go. First word, evaporation. Cooling process by which water is changed from the liquid form, which is water, to the gas form, which happens to be water vapor. Thinking about evaporation, we've talked about several possibilities or examples of evaporation. We talked about oceans, and we looked at principles of desalination. What was one principle that we used in desalination as far as evaporation goes? Somebody remember? Danny? Desalination. One method used evaporation. Remember what that was?
The water evaporates and the salt stays.
Okay. Salt stays, evaporation, water rises to the top, runs down the side. You can collect that fresh water. Now, evaporation, this is the most important thing you need to know about evaporation is it's a cooling process. And we're going to do a little mini lab over here that's going to look at that in a little bit more detail and give you a better chance to understand that it's a cooling process. And what you're looking at basically is taking water from its liquid phase and putting it to its gas phase. And there are probably 50 different variables that can influence the rate of evaporation, and we'll talk about a few of those too. Does everybody got this? Other term, the two major ones, we're looking at evaporation, and this is the second one, condensation. Basically, you can say that these two are opposites. You take evaporation, you take water in the liquid form, and you transfer it into water in the gas form. Condensation is just the opposite, where you take water that is in the gaseous form and convert that into water in the liquid form. Condensation, process in which gaseous water, which happens to be water vapor, is changed into a liquid form, which would be regular water. Anybody think they can give a good example of condensation? Or some time when they've experienced what they thought was condensation? Curtis?
Well, I do. In the morning.
Okay, dew on the grass. If you happen to get up nice and early, and it depends on the environmental situation, and take off your socks and shoes and go running barefoot through the grass in the morning, your feet might get wet. That's from dew or water that was out of the atmosphere that has collected on the grass. That's one example. Another example of condensation. I'm sure you've all experienced it. Nathan?
When, like, it's cold outside and you breathe on the window glass.
Okay, that's one. Cold outside, you go up to a window itself and you breathe on the window. You have, every time you exhale carbon dioxide, other gases, as well as water vapor. The water vapor in your breath hits the window, it cools and collects, and that's condensation. Another one. Rod?
Like when you're cooking and the steam from the pan hits the lid.
Okay, that's one. You're boiling something, cooking something, you take the lid and lift it up, and there's water that's collected. You take the lid and set it on the stove, and then you have water that runs everywhere. Another really good example. You've all experienced. A picture from the book. Exactly. You take a cold glass of water, take it out, set it on a table or whatever, especially in summertime, you come back, and then there is moisture all around the outside of it. I did this, we'll do it here in just a little bit. One time I was talking about condensation with these 4th grade kids, and I asked them, I told them, here's a glass, it's got water on the outside. I want you to tell me how this got here. We need to come up with how it is. And I said, you can only tell me, or you can only ask me questions that end in yes and no. And we sat there for 45 minutes, they asked me questions. Mr. Turner, yes. Mr. Turner, and I said, no. when they finally came up with the reason why condensation takes place. Now, we know that condensation is water collecting on the outside of the cup. What I want to know is why. This is my question I pose to you. TJ, what do you think? If I take this Pepsi can, and right now, I can pick it up and feel it, and it's got water on the outside of it. Why does this have water on the outside of the Pepsi can?
It's like cooler on the inside and warmer on the outside, so it's like evaporating.
It's like evaporating? Okay, he's got some good points, and right off the bat, he's got pretty close. What do we know about two things? First of all, this Pepsi, is it warm or cold? It's cold. When you take, example, condensation, and you take water from a gas form, or like water vapor, and you try to turn that into water as a liquid form, what do you have to do to that water, or that water vapor? To get it to go from a gas to a liquid. It's the same thing you have to do to make it go from a liquid to a solid. Curtis?
You have to take the heat out of it to make it go from a gas form to a liquid form.
Okay, what's another way to say take the heat out of it? Cool it. If you cool water vapor, it turns into liquid. If you cool liquid, it turns into solid. Why do you think that the water vapor in the air is collecting on the outside of the Pepsi can? Because it's cooler. And what's that do to the air around the Pepsi can? It cools it, and the water vapor in that air around the Pepsi can cools and turns to water and collects on the outside of the Pepsi can. That's condensation. And there are 100 examples. Everybody got this? We'll talk more about this a little bit. Next one. Saturated. Term used to describe the air when it is at the limit for the amount of water vapor that it can hold. This one, you can use saturated to describe a great deal of things. The one we're looking at is the atmosphere. The air in the atmosphere will only hold a certain amount of water vapor. When it reaches the point where it loses its ability to hold water vapor, what does it do? Jim? It rains. Or you get a rapid temperature change, and then suddenly a cloud can't hold as much water vapor as it could before, and then it rains. Another thing to use to describe saturated. Nice dirty sponge here. Is this sponge saturated? Caleb? Why not?
Because there's no water in it.
There's not much water. How could I saturate the sponge? Okay. Submerge it to a point where if I tried to mop up a spill or something with this, that it wouldn't pick anything else up. It's got all these nice little air pockets in here that trap the moisture or the water, and once it gets saturated, it can't hold anymore. And it gets to the point where it's saturated and holds it up, what will it probably do? It's going to drip. So it's only holding a certain amount of water, and eventually it's going to start giving some of that off. Other things you can describe as being saturated. A few days ago, or last week, the soccer field were saturated. We had so much rain for an extended period of time that it couldn't hold any more water. If ground gets to the point where it's saturated, what usually happens? Flood. The water can't go in the ground, it's got to run up on top, and usually run downhill. Like the video we watched last class period, talking about those canyons and things up in Colorado, and that first attraction over in England, where they got 30 inches of rain one day. Ground can't hold that stuff that quickly, it gets saturated. So that's that thing. We're focusing on the amount of moisture that the atmosphere can hold. Next term. Term you're all familiar with, you've heard several times, I'm sure. Humidity. Very simply put, water vapor in the atmosphere, or water vapor in the air. That's humidity. Is it humid today? Yes, it's very humid today. It's been raining off and on. We're probably going to get rain again today. So the humidity or the water vapor in the air is fairly high. What's one characteristic about humidity? What humidity usually do?
Flattens your hair.
Okay. Those girls just hate it when your hair gets flat. Other thing, you go outside and would you rather be outside working in the yard on a day that's 90 degrees and very humid, or a day that's 90 degrees and not very humid? Okay. It gets sticky, muggy, it's not very comfortable. You sweat usually a lot more easily on humid days because there's a lot more moisture. Next one. Term that you should see on the news or hear on a regular basis, relative humidity. The measure of the amount of water vapor actually in the air compared with the maximum amount that the air can hold at a certain temperature. Measure of the amount of water vapor actually in the air compared with the maximum that the air can hold at a certain temperature. Now, when you look at air, this is the property we need to discuss. Air is made of gas molecules, whether that's oxygen or carbon dioxide or nitrogen. There are many gases you can put in. What you have to know is about the particles in the air, or the molecules in the air, at different temperatures. Example of this. Doing dishes. What water usually works better to clean dishes? Cold water or hot water? Why does hot water work better than cold water? What's happening to those water molecules in hot water versus cold water? It has to do with speed. What? They move faster. They're moving faster. So they're more active to get whatever you're trying to get off that plate or to get it clean. If you take two sets of water molecules, one moving very slow, one moving very quickly, the ones moving quickly have more space between the molecules. The cold ones are usually kind of bunched up. The warm ones are just all over the place. And they've got all this space between them. Now, if you look at air molecules, they're the same way. The warmer the air, the faster those air molecules are moving, and the more space